Hello everybody, welcome to Mathethics original channel. Thank you for watching our videos. Please don't forget to like, share and subscribe. In today's video, we will write the recursive formula for quadratic. The recursive formula for quadratic. So let's begin. So I have two tables here. I got a couple tables, so I'm gonna use those tables as an example so you can see the steps that I take to write out the recursive formula for those quadratic. But first, we need to identify if this table are really quadratic function. So how do we do that? The first thing is to check for the first difference. So what we're gonna have is, so what do I add to 36 to get 49? So we know 36 plus 13 equal 49. So we add 13 here. And what do we add to 49 to get 64? So 64 minus 49 is 15. So we know 49 plus 15 equals 64. So what do we add to 64 to get 81? So 81 minus 64 is 17. So we add 17 to 64 to get 81. And we do the same thing. And 100 minus 81 is 19. So we add 19 to 81 to get 100. So that's called the first difference. And as you can see, the first difference is not constant because the number keeps changing. So therefore, we gotta find out if we have a constant second difference. So what we're gonna do here, we're gonna say what we add to 13 to get 15. So and that will be 13 plus 2, that will be 2. And 15 plus 2 is 17. And 17 plus 2 is 19. Okay, so that's the second difference. So we have a second difference and it is constant. So therefore, we know this one, this table is to represent a quadratic function. Now, how do we write the recursive formula? When you're writing the recursive formula for quadratic function, is the same thing as if you're writing the recursive formula for linear and exponential function. So we always start with f of x. Since we have f of x, we got x here for variable. So it's going to be f of x equal. So the next term is always the previous term. So every time you're doing recursive, you got to know the previous term. So it's the previous term, which is f of x minus 1 plus some type of number plus something. So we need to put something in this box right here. Now, what do we put in that box? Okay, so what do we need to put in that box is the that is the we have to find the explicit. So this is the explicit formula of the first difference. The explicit formula of the first difference. So now we know that our first difference is 13, 15, 17, and 19. So this is the first difference. And it's linear. So that's our first difference. of first difference, and it's linear. So what we need to do is to write, the explicit formula for the first difference. So to do that, we're gonna use the first number on the first difference, which is in this case 13. So we're gonna have 13 plus the common difference that we have, which is 2, the second common difference, plus the second common difference, which is 2, factor of x minus, now that 13 is the second term, okay? The 13 is with the second term, okay? So if we make a line right here, you can see 13 is attached with the second term. So therefore, that's going to be minus 2. So that's going to be minus 2. And we can simplify that, make it 13 plus 2x, and 2 times negative 2 is negative 4, become minus 4. So we just apply the distributive property here. 2 times x is 2x, and 2 times negative 2 is negative 4. So combining like term, we're going to have 13 minus 4, which is 9. So we're going to have 2x plus 9. So that 9 that we got is the number, is the expression. This 9 right here, this 2x plus 9 is what we're going to use to bring in this box here. So our recursive formula for this quadratic is the recursive formula is f of x equal f of x minus 1 plus 2x plus 9. Now, let's do this example right here. First, let's check to see if it is a quadratic function. Alright, so we know 9 minus 3. 9 minus 3 is 6, so that is the minus 3 here. And we know 6 minus 1 is 5, so that's minus 1. And we know 5 plus 1 is 6, and 6 plus 3 is 9. So that's the first difference. So negative 3, negative 1, 1, and 3 are the first difference. Now we need to find the second difference before we decide if it's quadratic or not. So the second difference, so we know negative 3 plus 2 is negative 1, so we add 2 to negative 3 to get negative 1, and we also add 2 to negative 1 to get 1, so we add 2 here, and we also add 2 to 1 to get 3, so we add 2 here. Now that we know it is a quadratic, and again this section right here is of first difference. This is our first difference, and it's linear. Okay, our second difference is constant, but our first difference is linear. So what we need to do first is to write the explicit formula for the first difference. For the first difference. Okay, so to do that, we're going on the first difference list, which is this list right here, negative 3, negative 1, 1, and 3, and the first number on the list is -3. So we're gonna have -3 plus, and the common difference, which is the second common difference, is 2. Okay, factor of x minus, and again the -3 is with the second term. Okay, -3 is with the second term, so therefore we're gonna say x minus 2. Okay, so now this 2 right here is the common difference. That's the second common difference. And this 2 right here is the term number. Okay, so now we can go ahead and simplify. -3. So when you simplify here, we can use the distributive property here. Okay, so we got -3 plus 2x. 2 times x is x, and 2 times -2 is -4. So minus 4. So and that's equal 2x. -3 -4 is -7, minus 7. So we got 2x minus 7. So now when you write your recursive recursive over here. So when you write out your recursive formula, so the recursive formula is f of x equal f of x minus 1 plus 2x minus 7. Okay, so that's the second example. We're gonna do another one. All right, so here's another example. So let's first check to see if it is a quadratic. So we know from 1 to 3 we add 2. From 1 to 3 we add 2. So 1 plus 2 is 3. And from 3 to 6 we add 3. From 6 to 10 we add 4. 6 plus 4 is 10. And 10 plus 5 is 15. Okay, 1 plus 2 is 3, 2 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. So that's our first difference, and it's linear, it's not constant. So now we have to find the second difference, which means we add 1 to 2 to get 3, so we add 1. And we add 1 to 3 to get 4, and we add 1 to 4 to get 5. So that's our common difference. Our common difference is 1. Our second common difference. So again, this right here is our first difference. Okay, and it is linear. This is our first difference, and it is linear. Okay, so now what we're gonna do is to write the explicit formula, for the first difference, To do that, we're gonna go back to the first different list, which is 2, 3, 4, 5, and the first number is 2. The first number is 2. So we're gonna have 2 plus the common difference, which is 1, factor of, so the common difference is 1, that's our second common difference, factor of x minus. Now notice these two are here. This 2 right here is connected with the second term. So that means it's going to be the second term. So x minus 2. Okay. So x minus 2. So we're going to simplify that. So we got 1x. So we got 2 plus x minus 2, and that would be 2 minus 2 is 0, so that's just gonna be x. Now when you write the recursive, so like this. So the recursive will be like this. The recursive formula is f of x equal f of x minus 1, which is the previous term, plus x. Okay. So here's another example. So first let's check to see if it is a quadratic. Okay. So from 2 to 0 we subtract 2. So that's negative 2 here. From 0 to 2 we add 2. So that's positive 2. From 2 to 8 we add 6. Okay. And from 8 to 18 we add 10. Okay, so that is our first difference. So now let's find the second difference for this one. From negative 2 to 2 we add 4. Okay. From 2 to 6 we add 4, and from 6 to 10 we add 4. And again, keep in mind, this is our first difference and it is linear. It's not constant. So that is our first difference. Now what we need to do is write the explicit formula. Write the explicit formula. The explicit formula for the first difference. For the first difference. Write the explicit formula for the first difference. Now the way we do that, we go on the first difference list, which is negative 2, 2, 6, and 10. So the first number here is negative 2. So we're going to have negative 2 plus the common difference, which is the second common difference, constant difference, which is 4, factor of x. Now, that negative 2 is with the 0 term. Okay, that negative 2 right here that we're using, that is the 0 term. So because it is the 0 term, it's pretty much minus 0. So that's minus 0 because that's the 0 term. So if we simplify that, so we're gonna get negative 2 plus 4x. Now keep in mind, x minus 0 is x, so that's simply 4x. So we can write it as 4x minus 2. Now the recursive formula is, the recursive for the whole quadratic is f of x equal f of x minus 1 plus whatever that thing is, that 4x minus 2, that's what we're gonna bring down here. So plus 4x minus 2. Okay, and that is your recursive formula for this. Okay, so we're gonna do one more example, then that'll be it for recursive. All right, here's another example. So let's first check to see if this is a quadratic function. So 14 to 9, we would add from 14 to 9, that's minus 5, so that's a negative 5. And from 9 to 6 is negative is minus 4, so it's minus 3. 9 minus 3 is 6, and 6 minus 1 is 5, and 5 plus 1 is 6. So that is our first difference. So let's check for the second difference. Negative 6 to negative 3, so you have to add 2 here. Negative 5 plus 2 is negative 3, and negative 3 plus 2 is negative 1, and negative 1 plus 2 is 1. Okay, so this right here is our first difference, and it is linear. Okay, so that's our first difference, and it's linear. So what we're gonna do is we're gonna write the explicit formula. We're gonna write the explicit formula for the first. We're gonna write the explicit formula for the first difference. The explicit formula for the first difference. So with that being said, we're gonna go on that first difference list: negative 5, negative 3, negative 1, and 1. So the first number here is negative 5. So we're gonna start with the first number, which is negative 5, plus the common difference. Now the common difference in this case is 2, so that's always the second common difference. Okay, that's the second difference. That's what the common difference is, the second one. So in this case is 2 factor of x minus, now the first number we used was 5, negative 5, and that negative 5 is connected with, so that negative 5 is part of the second term, negative second term, so that's negative 2. So because that's negative 2, so it's pretty much like negative minus 2 right down here. So that's negative minus 2 minus negative 2, right? So negative, two negative together change to a positive, so that become a positive 2. Okay, another way you can look at it, whatever that sign is, you just put the opposite sign. If it's positive, then this is negative. If it's negative, then this is positive. Okay, so whatever this sign is, use the opposite. Again, if this is positive, then I make this negative. If it's negative, then I make it positive here. So since it's negative here, so I make it positive. So that's another way you can look at it. So now we can use the distributive property to simplify. 2 times x and then 2 times 2. So we're going to have negative 5. 2 times x is 2x plus 2x. 2 times 2 is 4, so plus 4. If you combine like term, negative 5 plus 4 is negative 1. So we're going to have 2x minus 1. So once you have this, then you're ready to write the recursive formula. So the recursive formula is f of x equal f of x minus 1, which is the previous term, plus 2x minus 1. So that's 2x minus 1 is that exact expression that we found up here. We just bring it down here, okay? So, and that'll be the recursive formula for the specific table or quadratic function, okay? So that's all for this video. So again, that's video was about, you know, writing the recursive formula for quadratic. The first thing you do is make sure the table, if you have any given table, make sure the table represents a quadratic function, okay? So the way you do that is by checking the first difference. So the first difference gonna be linear. It's not gonna be constant. So the first difference going to be linear, and because the rate of change gonna change, right? So the number that you add to the previous term to get next term gonna change. And then once you find the first difference, then you check for the second difference. Now the second difference must be constant, okay? So that must be a single number that you keep adding to the previous term and get your next term. So that number doesn't change. So that's why we say it's constant. So if it's not constant but it's not quadratic, okay? So you do the first difference. So the first difference is not going to be constant. It's going to be linear. Then from that first difference, you do a second difference. That second difference is supposed to be constant. And that's how you know you have a quadratic. So once you identify the table as a quadratic function, then you go ahead and write the explicit formula for the first difference. Okay, so the explicit formula, you take that first number or the first term of the first difference plus the second difference factor of x plus the term number. Okay, just the way I do on those examples. Okay, so thank you for watching. If you have any question, please let us know. Any suggestion, any comment, let us know in the comment box. And don't forget to like, share, and subscribe, and I'll see you in the next video.